Welcome to my channel. Please don't forget to subscribe, like, share and comment. In this math tutorial, the first part of the question requires us to show that this integral is equal to that by using u-substitution. So we are going to let u is equal to e to the power x minus 1. And in this regard, e to the power of x is equal to u plus 1. And we can find du dx, okay, from this, and that will be equal to e to the power x. And we can find dx in terms of du from this equation. We'll say dx is equal to du over e to the power of x. So we are going to substitute this onto that part, and this u is going on that part, and this e to the power of x will go to that. All right, now let's do it. So we're going to say this integral, we can just call it I. We'll say I is equal to 3. Remember, we said e to the power of x is equal to u plus 1. So 3u plus 1 minus 1. Then dx is equal to du over e to the power of x. So we replace dx with that, e over e to the power of x. And then you remember we said u is equal to e to the power of x minus 1. So we've got u squared on the denominator. All right. But we need to again substitute this value of e to the power of x from here. All right. But we can expand what we have on the numerator. So we are saying I, the integral, is equal to the integral of 3u plus 3 minus 1 divided by u squared du over e to the power of x is u plus 1. U plus 1. All right. So let's simplify that integral further. We are going to say the integral I is equal to 3u plus 2, okay, then u squared multiplied by u plus 1 du. Then we have managed to show that this integral is equivalent to that by using u-substitution. In the second part of this question, we need to evaluate this integral. Remember, we have a result that we had by u-substitution from above. So we are going to be using that, but we need to change the limits because we are going to be integrating according to u. So we are going to change the limits, and we are going to use this formula that we just got from above. We said u is equal to e to the power x minus 1. So now we are going to say when x, the lower limit, when x is equal to ln 2. So when x is equal to ln 2, we have u is equal to e to the power ln 2 minus 1. And according to the laws of logarithms, e to the power ln something, you just get that something, which means that's going to give us 2 minus 1. Then we say u is equal to 1. That is when x is equal to ln 2. So we've got our lower limit for that. Now when x is equal to ln 4, u is equal to e to the power ln 4 minus 1. And that's going to give us 4 minus 1, and u is equal to 3. Okay, so we are going to change these limits. And you remember we said from above that this integral, when we use u-substitution, we said this integral 3ex minus 1 over e to the power x minus 1 squared dx can be written as 3u plus 2 over u squared u plus 1 du. Right. Now we are required to evaluate this integral, that is the lower limit of ln 2 and the upper limit of ln 4. So you remember we said the upper limit is 3 and the lower limit is 1. So we are going to evaluate this integral, all right? But we shall need to do integration by using partial fractions. So the main focus for now must be for us to decompose this into partial fractions. So we are going to say now 3u plus 2 divided by u squared u plus 1 is equal to a over u plus b over u squared plus c over u plus 1. All right, now we have got the lowest common denominator, that is u squared, u plus 1. So we are going to multiply with that throughout the whole equation. So we are going to have 3u plus 2 is equal to a u plus 1. Like when you multiply this by that, you are going to get that. Then plus b u plus 1 plus c u squared. All right. Now we are going to use the cover-up method of decomposing into partial fractions. We are going to say let u is equal to minus 1. We are eliminating this part and that part so that we are going to solve for c. So we're going to say now minus 3 plus 2 is equal to, this is going to give us a 0. We'll get a 0 on that. So we are going to have minus 1 squared for c. So we're just going to get a 1. That's for c. And then minus 3 plus 2, we are going to get a minus 1. So we say c is equal to minus 1. Now to find the term that contains b, we are going to let u is equal to 0. All right, so that we get rid of that and we get rid of that. So we are going to say now, let u is equal to 0. Let u is equal to 0. So we get a 0 for that. We remain with 2 is equal to, we get a 0 on that and a 0 on that. We have b, then 0 plus 1, that's just 1 times b. So we are saying b is equal to 2. Now we're looking for a. Now for a, we need to just take any number. We can take 1. 1 will be very easy for us to work with. So we're going to say let u is equal to 1. So we now substitute that into that equation. So we say 3 times 1, that's 3 plus 2, we get a 5. Is equal to, we haven't found a yet. So we're saying 1 plus 1, that's 2. 2 times 1, you just get 2a. And then b, you remember we said b is 2. Then 1 plus 1, that's 2. So 2 multiplied by 2. And then plus, you remember c is minus 1, and you're putting a 1 there. So we're just getting a minus 1. All right. So we are saying now 4 minus 1, you are going to get you are going to get 3, right? And then you take the 3 to the other side, you are going to get 2. 2 is equal to 2a. In that regard, we say a is equal to 1. From above, we found that c is equal to minus 1, b is equal to 2, a is equal to 1. So now we can write this 3u plus 2, we're just decomposing it into partial fractions now. U squared, u plus 1 is equivalent to, you remember we say a is 1, so that's 1 over u plus 2, that's for b, over u squared minus, we said c is minus 1, u plus 1. So we are going to integrate that. All right. So we are going to say now our integral, the integral that we require is equal to, remember we said the upper limit is 3 and the lower limit is 1. So we're going to say that's the integral of 1 over u plus 2 over u squared minus 1 over u plus 1 du. All right. Now we're going to integrate that. So we're going to say I is equal to, we're going to say ln u. If you integrate that, then that's going to give us minus 2 over u if you integrate that, and we have minus ln u plus 1. Then we put our limits from 1 to 3. All right, now we can just use the laws of logarithms. This is subtracting that. So you know, from the laws of logarithms, we're going to say now I is equal to ln u over u plus 1 minus 2 over u, with the limits from 1 to 3. Now we're going to substitute the limits now. We're going to say I is equal to ln 3. Okay, I'm putting a 3 wherever there's u, over u plus 1, that is 3 plus 1, you get a 4. Then minus, that's 2 over 3. And this will be subtracting ln u is 1 in this case, so 1 over 1 plus 1, that's 1 over 2. Then minus 2 over 1, that's just a 2. All right. Now we are going to simplify that further. We are going to say I, the integral, is equal to ln 3 over 4 minus ln 1 over 2, this one, then minus 2 over 3. The negative is multiplying that, so we say plus 2. And we say the integral I is equal to, if you are subtracting, that means you are going to divide 3 over 4 by 1 over 2 by the laws of natural logarithms. So you're going to say this is equivalent to ln 3 over 2. And if you do the math on that, you are going to get 4 over 3 plus 4 over 3. Then we've managed to evaluate that integral. Thanks for watching. Please don't forget to subscribe, like, share, and comment. Enjoy your day.